Okay, this lesson is derivatives of chain rule using the product and quotients. Okay, it gets a little bit more challenging right here, so find each derivative. Okay, so here I'm going to do a chain rule with this guy right here, and it's a product. So I'm going to go f prime g plus fg prime. Okay, so so it's going to be the derivative of x squared times the square root of the 1 minus x squared plus x squared times the derivative of 1 minus x squared. Now I'm going to do a little u substitution with this guy right over here. So I let y equal this guy right here, which is 1 minus x squared to the 1 half. So I let u be the inside stuff, so I have y equals u to the 1 half power. So dy du is going to be this 1 half comes out in front, so it's 1 half, and there should be a fraction thing right there. So 1 half u to the negative 1 half, and then du dx is negative 2x right there. Okay, and this 2 right here and this 2 cancels out, and this u to the negative 1 half becomes u to the positive 1 half downstairs, which is the square root. Okay, so I get this right here, so this is going to go in right here, and a 2x is going to go right there. Okay, you guys with me? Now, then I started looking at the answer in the back of the book, you guys, and so to match the answer in the back of the book, what they did is they made this guy over 1, and then they got a common denominator between this one and this one, which is this radical right here. So I'm going to go ahead and multiply this side by 1, but my 1 is going to get me a common denominator right here, okay? Now I have the same radical here, makes the radical disappear, so I'm left with 2x times the inside stuff. All right, and so I distribute that through, and then I get the answer that I found in the back of the book. Is that one right there. All right, let's try another one, you guys. Okay, y equals the sine cubed of 4x. I'm going to rewrite it as y equal the sine of 4x quantity cubed, and then let u be the sine of 4x. So I have y equals u cubed. All right, so what I did was is since I'm going to find the derivative of this, I did a y equals the sine of 4x over here. Whoops. And then, I let u equal to 4x, so I have y equal the sine of u. So dy du over du dx is going to get me, here's dy du is cosine of that, so dy du is cosine of that. And then du dx is that 4 right there, so it's 4 cosine of u, then I put the u back in, which is 4x. Alright, so here we go. I'm going to put this 4x over here. It's going to be my du dx part over here. Alright, so here's this right here. So I left it in the red right here. So dy du is 3u squared, and then here's du dx. I did that over here. Okay, then I'm just going to substitute in u back in here. So the sine of 4x, so it's the sine squared of 4x right there. That goes in right there. So you get, and then the 3 times 4 gives me 12 sine squared of 4x, and then cosine of 4x. All right, let's try another one here. Okay, so here I have a quotient rule right here. So I'm going to let u be that inside stuff right there. So I have y equals u squared. Okay, so then y prime is going to be 2u times this guy right here. So the derivative of that right there. So I'm going to take care of this over here. So the quotient rule is f prime g minus fg prime all over g squared right there. Okay, so the derivative of this is 3x. The derivative of this side over here is 2x. Okay, so I get 3 times, 3x, or 3 is the derivative of this. So I'm going to distribute the 3 through. I'm going to distribute this 2x through and the negative through on this side right here. You guys with me? All right, so and then clean it up on top right there, and then that's going to be this little piece right here. Okay, I just did the quotient rule with that guy right there. All right, so substitute that back in there, and then go ahead and leave the numerator like that, because this ends up being your x-intercepts. You'll find out the reason why we want our x-intercepts for that later, you guys. Okay, so it gets more challenging as we keep going, so get plugging away. Make sure you're doing your homework on this, and if you are in my calculus class, I would assign that as your homework right there.